All right. Well, hello, everyone, and thank you all for joining us for some fun science learning and hands-on activities this weekend. My name is Alana Rapp. I am a fourth-year student here at UW-Madison studying environmental science and German, and I work as an education and outreach assistant at the Wisconsin Energy Institute. And a fun fact about me is that I am a huge Harry Potter fan. So thanks so much for joining us today for the Wind Design Challenge, and we'll get right started then. So some quick information on the Wisconsin Energy Institute. It is the home for cross-disciplinary energy research here at UW-Madison. We support over 160 researchers studying things from microgrids to biofuels, and we also support the next generation of energy experts via certificate programs at UW-Madison. So if you're thinking about college and you're interested in energy, definitely consider checking those out. And we also do a variety of public outreach and educational programs, such as this one today and this weekend. So a quick overview of what we'll be doing today. We'll begin with an introduction to wind energy and then dive right into the hands-on design challenge that is the main focus of this activity. Then we will discuss our takeaways and finish with a quick wrap up on the future of wind in Wisconsin. So why should we care about wind power? What's so interesting about it? And feel free to pause the video now and just think a bit about what your answers to this question might be. You can jot them down on a piece of paper or just say them out loud. I also meant to mention before that I'll ask you guys to pause your videos a couple times throughout this activity, either to answer a question or to work on an activity. So here's the first opportunity. Just think about why is wind power interesting to us, and what does it offer? What are its benefits? So why should we care about wind power? Well, a little bit of background on wind power. Wind turbines make electricity. The wind turns the blades, which are connected to a generator, and that produces power. This electricity can then be used in a variety of ways, including for lighting, heating, and electronics. In contrast to fossil fuels, wind energy is renewable and carbon-free. This means it uses Earth's resources, like wind, that is, that are naturally replenished. And it also does not emit any fossil fuel gases, or like greenhouse gases, that is, such as fossil fuels do. And it is carbon free. So this means that it is a sustainable form of energy and renewable. It also offers a lot of counties and cities that use wind energy, local energy independence. So they're not reliant upon big fossil fuel energy companies to provide them with their energy. Instead, they can produce it nearby. And in the same line of thought, it also often provides local jobs to communities that are installing it. So here are two pictures actually from a wind farm in Wisconsin. So that's a cool local example. So today, we will be building a windmill that looks like the image on the right here. So the difference between a windmill and a wind turbine, like the picture on the left, is simply that a wind turbine has a generator, whereas the windmill does work by lifting weights, like you see on the picture here. When it turns, that string spins and the cup at the bottom will be lifted. And that's how it does work. So, but there are lots of similarities too. I'm sure when you look at these two pictures, you can see they both have blades, they both have a hub and a drive shaft or a tower. So pretty similar. So the materials that you guys will need, here's a quick overlook of them for the activity today. Some of these can be quite flexible, so don't feel constrained by the images you see here. Whatever you have around the house that you feel like can work for these different parts are definitely give it a try and go for it. There's no restrictions on what you can use other than trying to get them, somewhat similar to these. So I'll explain a few alternatives to the ones we see on the screen here. So first of all, we'll need a fan or a blow dryer, some sort of source of wind. And then you'll need maybe cardstock or index cards for blades. If you don't have those, you could also cut up paper plates or plastic bottles. For a hub, you can use a styrofoam ball, kind of like this one I have here. Otherwise, if you don't have that, you can also look for maybe some Play-Doh or putty, something that you can stick sort of like these wooden dowels into, or you can tape it to. And then you'll need something for a drive shaft. That could be these wooden dowels or pencil maybe, or a small stick from outside. Then you'll also need some sort of hollow tube that this drive shaft can sit inside of. So that can be a straw or maybe an empty toilet paper roll, such as this one here. And the straw, now my drive shaft just fell off, but the straw will go around the drive shaft. So just anything that is slightly bigger and can go over the drive shaft so that the drive shaft can spin around inside while you hold tight to the straw without impeding its motion. So that's what that is for. And then T-pins are to stick the blades into the hub. However, you can also maybe use like unraveled paper clips or anything that is kind of pokey, be careful, or maybe just tape, to anything that you can think of how you might attach your blades to that central hub. And then don't worry about the cup and the weights in the last image. We might get back to that, but the main focus is to build the turbine itself first. So yeah, feel free to pause the video now and go on a scavenger hunt and gather the items that you can. Perhaps you saw in the register or in the description of this activity already saw some of those materials and had a chance to gather them. In that case, can go right ahead, but otherwise feel free to pause the video. So what has this got to do with engineering? So engineers often deal with problems, right, they need to find a solution. So that's what we have today. We have the issue or the challenge of building a wind turbine with all these different materials we've collected, and we have to find some sort of a solution. Well, our challenge specifically is to make it spin. So, and then finding a solution involves designing it and coming up with ideas, and then building and testing and revising your design and using your creativity and engineering mind to overcome the challenges that you face. So that's what we'll be working on today. So your challenge is to build a windmill that spins. When you hold it in front of the fan and turn the fan on, that the windmill is spinning. So the first step is to design. And so we would love for you now to pause the video and grab a piece of paper and a pencil and draw a sketch of what you would like your wind turbine to look like with the various materials that you've collected. So just draw that out and label the various parts and the materials. Go ahead and take a few minutes and pause the video now to do that. Next will be to build a prototype and test your fan. So this is sort of a cycle process. You'll build the prototype, test, adjust something, test, so on and so forth, until you kind of get something that is spinning if you can. It's not easy, so don't feel discouraged if it's not working at first, or if you're having some trouble to get it to spin. Just keep on trying different things and enjoy the process. So at this point, you can pause the video for maybe 10 minutes or so and try and build your first shot at a prototype and test it. When you unpause the video, I will have some tips ready for you that might help you once you've tried to design for a little while. So when you're ready for some tips, feel free to unpause. So some extra tips that might be useful to you in working through trying to design your windmill. First of all, be careful when poking into your styrofoam hub. I find that sometimes if you poke too much, then the hole gets a bit too wide, and then these blades start to just rotate around and maybe even fall out, and they just don't stay secure in there. So be deliberate with, like, when you're using, if you have a styrofoam ball, how you're poking it. And then consider how big your fan is. So does it make sense for your blades to be bigger than your fan? Say that your fan face is only this big, but your blades are all the way out here. They might not be catching as direct of a line of wind as would be useful. So maybe then try and make your design a little more compact to fit the size of your fan. So let's go back. Another tip is, are more blades better? Test it. Maybe you started with 4 blades, maybe try 5 or 6. If you started with 3, maybe try 2 or 4. Just try different numbers of blades and see how they work. And then lastly, just try it. And I kind of alluded to this earlier, but scientists and engineers often use a method to do their experiments called isolating, or testing one variable at a time. So for example, say you want to change the size of your blades, switch out the blades, only those, and then test it again before you tweak something else. And then maybe you want to add another blade, add one more, and then test it again, and just change one thing at a time and test so that you can really narrow down what it is that is most helpful for your design. Also, have you considered blade size, blade shape, number of blades, as we said, blade materials, what serves as your hub, and what parts spin and what parts stay steady? So for example, if I can reassemble mine really quickly, just a moment ago fell apart a little bit. So when I hold my windmill in front of my fan, I'm holding onto my straw here, and you see that that allows this, well, now I'm spinning it at the end, but if the fan were going, that allows this to turn around, the drive shaft to spin without me stopping it. Now, if I didn't have the straw and I was just holding onto the drive shaft, it wouldn't be able to spin, right? So we've got to make sure that you have something to put over the drive shaft that allows the windmill to spin within it. So feel free to pause the video now if you'd like and try a couple new things, adjust your design a little bit, and then come back. So on to the discussion. What was an awesome struggle that you guys had? What was something that was really a challenge that you grappled with and you kind of came up with some ideas for and maybe conquered it, or maybe moved on to a different thing, or just kind of struggled through? Because those are really good. That's what it's all about. It's all about that process. For example, I struggled with the pitch of my blades, so the angle of them. So I found that at the beginning, I had them too flat and they weren't catching the wind well enough. But then if I turn them fully up, like upright like this, where it was, then the wind is just going straight around them and not catching them. So I had to find a good medium point where I could catch the wind properly. How did you guys attach your blades? How many blades worked the best for you? What number was best? Was there any friction in your design? How did you reduce that friction? Was anything rubbing against another thing when you tried to have your windmill spin that was preventing it from spinning as well? How did you pitch or angle your blades? Did you notice anything about where you put the fan in relationship to your turbine? What variable had the biggest impact? This one's a really interesting question. Definitely, I encourage you to think about that. And then what would you change about your current design going forward if you had to adjust a little bit further? Feel free to pause the video and answer any one of these questions, or as many of them as you'd like that you find interesting. You can say them out loud, say them to yourself, or if there are other people around you, or write it down. Just kind of reflect on the process of building this windmill. So we're going to wrap up the lesson today with just a little bit of information about the future of wind in Wisconsin and the present situation. So currently in Wisconsin, wind energy that is installed represents 3% of Wisconsin's total electricity produced. On the right here, we have a map where you can see the various locations of different windmill farms or wind farms across Wisconsin. You can see quite a few of them are located near Lake Michigan, which makes a lot of sense because the wind is coming off pretty strong from the lake there. And here are some values and numbers that are kind of summarizing what wind is like in Wisconsin currently. So what comes next for you? If you are interested in wind and wind energy or renewable energies, well, I'm glad to tell you that wind turbine technicians and solar installers are two of the fastest growing jobs in the US. Also, lots of schools like UW-Madison have extracurricular groups such as the team Whisk Wind, which I'll talk about in a moment, or energy sustainability certificates that allow students to engage more with their interest in wind energy. There's also similar programs at Lakeshore Technical and Madison College. And then finally, we host something at Wisconsin Energy Institute called KidWind. This was just recently happened for us last weekend, so it'll be coming again next year, I believe March 5th. And that's a really great challenge where middle school and high school teams can sign up and build a wind turbine of their own, and then hopefully next year they'll be able to come to the Wisconsin Energy Institute and test them there and see who produces the most energy, along with a bunch of other activities, instant challenges, and speakers. So here's some cool pictures of the Whisk Wind team, what they do. They also build, similar to KidWind, a wind turbine and then test it, only they use 3D printing and make their own generators and such to do this. And yeah, very cool organization on campus. And finally, here's some interesting information if you're interested in a career in wind. You can follow this link here. You can just type this into your URL box and see play around with these different levels of and different categories of wind careers. So on the bottom, we have different categories, and then we have different levels here on the left, early and entry level, mid, and advanced. And you can click on any one of these dots and they'll give you more information about what those jobs are. Oh, just clicked on it accidentally. So, oh, goodness. Uh, Well, that was the end of our presentation. So wind energy I already, or Kid Wind I already talked about. Um, yes, if you're interested in that, definitely contact the Wisconsin Energy Institute or go here to go.wisc.edu/kidwind. And yep, that's all. Thank you guys so much. Feel free to contact Allison Bender. I work with her at the Wisconsin Energy Institute if you have any questions about Kid Wind or anything else that we talked about today. Goodbye.